this lecture is going to go over pH calculations. You're going to want to make sure you have your calculator as well as your objective sheet. Now with your calculator, if you're having difficulty getting the numbers that I am, it might be that you're typing things in your calculator incorrectly. So your calculator might be different than someone else's calculator, which might be different than mine. It just depends on what calculator you are using. So come see me if you are not getting the same answers that I am here. So before we start with calculations, we want to talk about what the pH scale is. So the pH scale is going to measure how acidic or how basic something is. But we know that it has numbers, 1, 2, 3, 4, all the way up to 14. Now, the first bullet here says every step up on the scale is by a factor of 10. So if I am going from a pH of 2 to a pH of 3, that looks like it's going up by a factor of 1. But really, every step is by a factor of 10. So that means that from 2 to 3, the concentration of the H plus ion, and we'll talk about that in a second, is 10 times more from when we go to the 3. If I'm going from a 2 to a 4, it's going to be times 10 when I go from 2 to 3, and then it's going to be times 10 when I go from 3 to 4, which means that going from 2 to 4 is by a factor of 100. So every step up that you go, or every step down, whenever you're going up or down a step, it's by a factor of 10, not by a factor of 1. So make sure that you are keeping that in mind. Next thing, acids will have a pH of about 1 to 6. We're just going to say that roughly for right now. Bases are going to be a pH of 8 to 14, and then if something is what we consider neutral, we'll look at it as having a pH of 7 for right now. All right, so what is the pH? We know if it's a 1 through a 6, it's an acid. We know if it's a 8 through 14, it's a base, but what does that mean? Well, the pH is your concentration of hydrogen ions in a solution. Now, if the pH is high, so 8 to 14, it means that your concentration of hydrogen ions is low. Now let's go through the next part before we explain this, because that might seem backwards. If the pH is low, the concentration of hydrogen ions will be high. Now, if you think back to especially your Arrhenius theory, we're making H plus ions, correct? So if I have a lot of these H plus ions, it's going to be an acid, which means that my pH level is low. So if I have a lot of H pluses, my pH is going to be low. If I don't have very many H pluses, meaning it's a low concentration, then my pH is going to be high, so then it's going to be a base. So it seems backwards, but when you think about it in terms of looking back at your Arrhenius theory and then looking at what you know your values to be for pH for acids and bases, this kind of makes sense from there. All right, so we also have something called a POH concentration, or POH, and this is the concentration of the hydroxide ion in your solution. So it's very similar to pH, except it's the concentration of the hydroxides instead of the concentration of your hydrogen ions. Now, an equation to remember is that your pH plus your POH is going to give you a total of 14. So, for example, if our pH is 3, then our POH must be 11, because 3 plus 11 equals 14. All right, easy enough with that. Now you want to make sure you have your calculator. We're going to do some calculations here. So to calculate the pH of an aqueous solution, you need to know the concentration of the hydronium ion in moles per liter. So you want to know the molarity. So if I give you the liters and I give you the moles, you're going to solve for the molarity. If I give you the grams and I give you the liters, you're going to have to convert those grams into moles and then solve for the molarity. But make sure that you are always getting to this point of having the molarity. Once you have the molarity, it's just a simple input in your calculator. Now, when we do this, we're really only going to be doing this for our strong acids because they are going to ionize completely. But that's just for reference, but you will be getting ones that are strong in your examples. All right. So then the pH, once we have that molarity, is calculated using the following expression. Your pH equals the negative log of the hydronium ion, or if it gives you just your H+, it's the negative log of your H+ ion. It's going to give you the same value here. Now, it depends what your calculator looks like. Some of your calculators, you're going to have to put the concentration in first and then put the log. Some of your calculators, you're going to put negative log and then the concentration. It all just depends on what your calculator looks like. Now, if you're looking at a TI 83 or higher, that's what I'm going to be using right now. That is when you're going to put in the negative log first. So calculating the pH. Find the pH of a 0.0025 molar solution of hydrochloric acid. Now, in this problem, this does not matter. Because we already have our molarity, we don't need to know that this is hydrochloric acid, okay? Because we found the molarity already from the fact that it was hydrochloric acid. Now, if I gave you the grams and you needed to find the moles, then you would need that molar mass to convert that. But right now, we don't even care that this is hydrochloric acid. So, remember that our pH equals the negative log of our concentration. So that's going to be a 0.0025. So if you type that in, you should get 2.6 as your pH, which means that this is an acid. Okay? So you're just putting negative log, putting in your concentration. So those of you using a TI 83 or higher, that log button is down your left-hand side of your keys. All right, well, let's say we're not calculating the pH. Let's say we want to know what the concentration of the hydronium ion is. So we're kind of working backwards here. What is the hydronium ion concentration in a solution that has a pH of 8.34? So what we're looking for here is we're looking for the molarity. So we're going to have units of molar on this. So when you are given the pH, so our H3O plus concentration equals 10 to the negative pH. That's your equation. Now we're not going to go through all of the math of how we got to this. It's really just a simple rearrangement. But this is your calculation. So our pH is 8.34. So we're going to take 10 to the negative 8.34. And we get 4.57 times 10 to the negative 9th molar. Now, from this, we know that this is a base, just based on the pH. Now, looking back at our pH on the last one we did, we had a concentration of 0.0025, which is 2.5 times 10 to the negative 3rd. This is a much smaller number. So remember we said the smaller the concentration, the higher the pH. So that's kind of where this is coming from. All right, so now pOH. We already learned how to calculate pH. Now we're going to do pOH. It is just the same, except now we are looking at the hydroxide ion instead of the hydronium. So to calculate the pOH of a solution, you need to know the concentration of the hydroxide ion in moles per liter, which is your molarity. Same thing as we saw before. So the pOH is calculated using a very similar expression, which is the negative log of your hydroxide concentration. So same thing, except we're plugging in the other value. We're not looking at hydronium or the H+, we are looking at the hydroxide. So what is the pOH of a solution with the hydroxide concentration of 4.02? So remember that means pOH equals your negative log of your concentration, which is 4.82 times 10 to the negative fifth. So plugging that in, is going to give me a value of 4.3, we'll round that to 4.32. So remember, this is your pOH, not your pH. Okay, so from this, we're not going to determine if it's an acid or a base, because we determine that based off of our pH concentration. But in a minute, we'll determine how to determine that from here. Okay, so keep this value in mind. How do I find the hydroxide concentrations? Same thing. You're going to take your hydroxide concentration equals 10 to the negative pOH. So doing 10, so with this one, looking for the hydroxide concentration of a pOH of 5.7, so it's negative 5.7, so it's equals 2.00 times 10 to the negative 6th. Our units on that is molar. All right, so moving on. What is the pOH if the pH is 11.6? Now remember that your pH plus your pOH is always going to give you a value of 14. So you can just plug these in. So 11.76 plus your pOH equals 14. Subtract 11.76 from each side. And your pOH equals 2.24. All right. So going back to this one right here, if our pOH is 4.32, that means that our pH equals 9.68, which means that this solution is a base. So you can find that from there as well. Now, go ahead and work on some practice problems. If you are having trouble figuring out where your log button is or what order you need to type things in, just come and see me and we will figure that out. Good luck.